Hello everyone. In this video, I am going to show my progress in implementing the BSHEFT algorithm. Firstly, I have created a workflow, which is an example workflow that has 4 tasks. As you could see, the tasks are T1, T2, T3, and T4. And firstly, we want to generate the weight for this workflow, create a weighted graph. And in order to do that, we have created 3 different tables. And you could see that the first table that I have is about the cloud. And the AWS Amazon EC2 cloud have these 5 different instance type. And each instance type has the number of instruction per minute and the data movement time per minute. Um, and you also see there is a cost associated to lease that machine per hour. And second table that we have is for each data dependency. We have shown the data size that is a part of that data dependency edge. And the third table is for all the 4 tasks. You could see the number of instructions that is going to be part of that task. Okay, so we have these 3 different tables which are mainly used to generate the weight for this graph. And as you could see, I have provided a weight of 0 to the input and output edge. I mean the final input and final output and the initial input. And secondly, in this code, I am assuming that the tasks are already assigned to the virtual machine in the cloud. And I am just assuming that just to um, create the logic for EST and EFT calculation. So for this sake, let's just assume that these 4 tasks are assigned to these 2 different machines. So the assumption is based on the T scheduler. So as you could see, 1, 2, and 4 are assigned to virtual machine 1, and the task T3 is assigned to virtual machine 2. So that's the initial assumption that I have made. And now I will show you the execution of the code. So firstly, let me go ahead and delete all the records in my table. And you could see that the table is empty now. And I am going to execute my code here. Okay, and then let's execute this thing. So it's going to generate the schedule and then store the schedule in the database. And let's go into our schedule table. You could see that there are 4 tasks and the virtual machine number that is assigned here, and then the start time and end time. So I have, for convenience's sake, I have captured this into my document here. So let's look at my document. So you can see the task T1 start in 0 minute, and then the total time it takes to execute the task on virtual machine 1. And what we mean here by 1 is it is going to be of type 1, the virtual machine type 1. And what is virtual machine type 1? It is T2.nano. And we already have the number of instructions that can be executed per minute and how much data can be moved per minute. So we have those 2 measurements that come as part of the cloud pricing table. So here, once we know that it's going to be assigned to virtual machine 1 because we made that assumption, you could see that we calculate the start and finish time. And for task T2, there is a dependency, right? As you could see from our figure, Task T2 can only be executed if T1 finish its execution, and the same thing with T3. So, and hence you could see that task T2 would start its execution from 15 minutes and all the way until 35 minutes, including the computation time and the data movement time. And once T2 finish its execution, in parallel, when T2 is getting executed, T3 will also start executing, because T3 can start its execution when T1 finishes its execution. And for T3, you could see that it starts from 15 um, minutes, and it will take up to 50 minutes. Why we have extra 5 minutes? Because we added the provisioning time. Okay, and you could see we have added the provisioning time even for task T1, because that is when the virtual machine 1 is being provisioned. So the logic would automatically detect that, the code will detect that this is a new machine, and hence we have added 5 minutes of provisioning time to the execution time, and we show it here. Whereas for task T2, it is already using the existing machine, so I have not added any provisioning time there. And for task T3, because this is a new machine, it's automatically add that provisioning time of 5 minutes there. And for T4, we don't add any provisioning time, but for T4, in order for that to be executed, firstly, we would like to know that when the virtual machine would be available. In this case, it is virtual machine 1. And when is it available? It can be available when it is like 35, right? When it's 35 minutes, it can be available. But then we should also keep that in mind that there is a waiting time for T4 to get executed. Why there is waiting time? Because T2 and T3 need to move their data so that T4 can start its execution. So we look at all the producers here, and we look at the maximum time taking producer. So in this case, what is the maximum time taking producer? It is going to be T3. So only at the 50th minute, T4 can start its execution. Although that the virtual machine 1 is available at the 35th minute, we still need to wait for 15 more minutes in order to start T4 execution. So I have done that logic internally in my code to make sure we consider both the virtual machine available time and as well as the data transfer is ready or not. Once the data has been transferred, then only the task can get executed. Okay, so now I have computed this EST and EFT based on my initial schedule that I have here. Now my next step is to follow our algorithm and not use this initial schedule, but instead use the schedule that's coming from the algorithm. Basically, the algorithm will allow me to select these virtual machine, but my logic for EST and EFT calculation does not change. So as a next step, I will make another video where I would show the actual working of the algorithm along with the EST and EFT calculation. Thank you for watching this video.